Hello, this is Mr. Stansbury. I'm going to take you through the notes on translations. At the end of this, you should be able to say, I can perform translations on and off the coordinate plane, and I can predict the effect of a translation on a figure. Okay, so first thing, translation is a rigid motion where every point on a pre-image, or P, moves the same distance and the same direction to form the image, or P prime. Okay, that's the notation for pre-image, and the new part is the image. Okay. Now, there's the function notation for this, which we talked about in the previous section. We have xy translates to x plus a and y plus b. The a is going to be the distance moved on the x-axis. If it's a positive a, it moves to the right. If it's a negative a, it moves to the left. And with b, it's the distance moved on the y-axis. Positive b moves up and negative b moves down. Okay. There's also something called T notation, which is translation notation. And instead of doing this whole mess here, you just do T of A, comma, B. Okay? For example, translate left 1 and up 2. With this notation, we would do this. We have, let's see here. On that one, we would do translation. Hold on a second. Okay. Our translation notation, x and y. On this one here, translate left 1 and up 2 is going to go x. If we're going to the left, negative moves to the left, so it's minus 1. And then the y goes up 2. Positive b is our up 2, so that's going to be plus 2. So that's our, that's in this function notation here. And then our t notation is simply just going to be translate, and we're going to go negative 1 for all the x's and positive 2, or just plain old 2 for all the y's. Okay, for example, B here, let's see, we've got xy translates to x plus 3 and y minus 5. So we could explain what that is. That's going to translate plus 3, so that's going to be to the right 3. And then negative 5 is down 5. And then our t notation is just going to simply be positive 3, negative 5. Okay, and then starting in t notation, we can explain it and then put it into this function notation here. So this is going to translate. Let's see, negative 2 is left 2. And then it's going to go up. Since it's positive, it's going to go up 8. Okay, and then that would be xy translates to x plus, no, not plus, but x minus 2, and y plus 8. Okay? All right, let's look at some of the examples from our textbook, shall we? So, this one here, 2 and 3. Mr. Scott arranges the band in a rectangle. Then he directs the band member at 610. So let's see, 610 is right here. That's that band member. Tells that band member to move to 413. So that now they're going to go to 413, which is right here. Okay. The numbers on the coordinate plane show yards of the football field. Okay. Now, for the band to move in a translation, how should each band member move? So really what they're going to do, they started here and they're ending here. So we have to go, let's do the X first. So we're going to go to the left 2. So we would go left 2. And then they would have to go, so we're going to go like this, and then we're going to go up 3. Left 2 and up 3. And this would all be in yards, right? Because this is a football field. Okay, we could write it in our translation, our T notation, which would be negative 2 and positive 3, right? Or we could also write it as xy translates to x minus 2, y plus 3. Okay? All right, number 3, critique the reasoning of others. Maria was positioned at point 24. So let's start over here. We're at 2, 4. Okay, and then her friend tells her that Maria's new position is described by the function x plus 3, y minus 2. So if we take our x and we add 3, 1, 2, 3, and we subtract 2, that would put us right there. Okay. So she said that her new position is described by the function x plus 3y minus 2. Since her new position is 7, 0, is her friend correct? Well, this here does not end up at 7, 0. This ends up at 5, 2, right? So is her friend correct? No, she is not correct. Let's see. Positioned, her friend tells her, oh, it could be him or her, is not correct because this here is taking them to 5, 2 instead of to 7, 0. How about this? Let's do the correct notation. Notation should be, let's see, so to get from here down to here, because it's supposed to be, she's supposed to be at 7, 0, right? So she would go 1, 2, 3, 4, 5 to the right. So it should be x plus 5. And then the y goes from here down to the bottom, so that's going to be subtract 4. So that's going to be y minus 4. That would be the correct notation to get her to 7, 0. Okay? Okay. I'm going to take a look at a couple more, but before that, let's take a little comedy break, shall we?
Where are you going? Where are you going?
All right. Last couple here. Okay, draw the image of the figure under the translation described by the function. So we've got xy is going to go to x plus 4 and y minus 4. So let's do this. This point here, we're going to add 4 to the x. So 1, 2, 3, 4. And we're going to subtract 4 from the y. 1, 2, 3, 4. So there's the new spot for that. Let's say if we take this one over here, we're going to add 4 and subtract 4 for the y, end up there. For this new spot here, we're going to add 4, subtract 4 from the y, and then for this last one over here, we are going to add 4, subtract 4. So we end up with this rectangle down here, which ends up looking like this. Okay? Again, last little, we've got one more to take a look at. Okay, last little set of problems here. Draw number 6. Draw the translation of the rhombus described by directed line segment AB prime. So this is some different notation when we're not using the coordinate plane. This is just out in regular old space without any grids or anything like that. So this AB, we almost want to think of this AB prime here. We want to think of this really kind of like a ray. So that would be like, let's do this so we can see it better. So it would be like starting from A, going up to B, and think of, we're going to take every one of the points and we're going to move it that far. Okay, so if we do that, that means that this D now gets moved up here to C. This C gets moved up here. This A gets moved up here to B, and then the B gets moved up to here-ish. You can kind of eyeball it here, and then P is also going to get moved to right there. We're going to end up with this new rhombus. It looks kind of like that. It's a little goofy, but you get the idea. Okay, so let's see, we did that one. Which part of the rhombus maps onto BC? So mapping means what ends up on this line here. If we take this whole rhombus here and we shift it all up this direction, this AB here, if we shift it all up that way, they're asking what ends up being on the CB line. So this, if you'll notice, we got this DA line right here. When we move it up here, it ends up right on top of this CB line here. So what maps onto BC? That AD line does. Okay? And then last one, identify a translation of the rhombus that would map exactly one point of the rhombus onto another point of the rhombus. So the key on this thing here is it says maps exactly one point. So what we could do is we could take, say, this. We could start at D, and we could draw the line over here to B, and make this here, make that our ray, our directed line segment, they call it. So if we took all the points and moved it straight over like that, this D would end up here, C would end up right there, B would end up about right here-ish, and then A would end up over here, and then of course P is going to still be in the middle there. Look, something like that. Okay, so if you'll notice, D gets mapped straight onto B, B goes over to here, this C goes over here, and this A goes over right here. And if you'll notice, this D maps straight onto B, and that's the only one point. Okay, now I'm going to erase a lot of this so we can also show a different way that we could have done this. And that would be, let's see, let's get rid of all that. What that would be, we could also go, say, like go from C down to A and move this whole thing down here, and we would end up with a rhombus looking something like that. We could move B over to D, end up with a rhombus like that. And we could go A up to C, and we'd end up with a rhombus like that, if that makes some sense. Okay, so all sorts of different options that we have on that. So we did identify the one that we did. We did the DB. Okay. All right, that's all we have for this translations section here. If you have any questions, please feel free to ask in class. Thanks.